Have you ever wondered, who drinks more water? Non-athletes or athletes? We have been wondering the same thing, and we can help. Meet the crew. Joseph Cronnin, Morgan Easter, Carrie, and Hannah. Here's how it works. We're going to conduct a study, gather information, draft the data, state and test the hypotheses, conclude and compare. So, do athletes drink more water per day? Let's find out.
Do you consider yourself an athlete or non-athlete? Yeah, athlete. How many bottles of water do you drink a day? 2. Okay. Do you consider yourself an athlete or a non-athlete?
No, non-athletes.
About how many bottles of water do you drink a day?
About 5 bottles of water.
Okay, I have a question. Do you consider yourself an athlete?
Yeah, sure.
Okay, well, how many bottles of water do you drink a day?
Maybe like 3.
Awesome.
Alright, do you consider yourself an athlete or a non-athlete?
Non-athlete.
And about how many bottles of water do you drink a day?
1, maybe 2.
Alright, thank you.
Hello again. We took a simple random sample of 3 athletes and 3 non-athletes from several different classrooms. We did this until we had 25 athletes and 25 non-athletes. In total, we surveyed 50 people. Basically, we did a stratified sample with the classrooms being the strata.
We reduced undercoverage bias by including both athletes and non-athletes in several different types of classrooms. We also worded the questions very easily in order to reduce the bias caused by question wording. Bias we still had was response and voluntary bias because most do not know exactly how much water they drink a day, and we only surveyed volunteers.
We chose to do a bar graph because they are easy to read and make. The graph of the athletes is more skewed to the left, while the graph of the non-athletes is more skewed to the right. For the athletes, 3 bottles of water was the most common response, while 1 bottle was most common for the non-athletes. Both sets of data didn't have any outliers, and the graphs were normal.
Here are the hypotheses. We chose null because it was known. For the alternate hypothesis, we chose the mean of athletes is greater than the mean of non-athletes because we think that athletes drink more water than the non-athletes.
Testing procedures. Assumptions. 2 independent simple random sample of people. Normal because graphed and appears normal enough to continue the test. Standard deviation unknown.
We used the 2-sample t-test. Our t equals 1.69, our p equals 0.049, our level of significance was 0.05, and our degrees of freedom was 46.89. This is the curve.
Since the p-value was less than the level of significance, we reject the null. There is sufficient evidence to suggest that athletes drink more water than non-athletes. This means our hypothesis was correct.
We can tell that our conclusion was true because more data is found to the right of the graph for athletes and left for non-athletes. So we figured that athletes drank more water. We can compare the degrees of freedom to the graphs because if you add up all the people we surveyed and subtract 1, we get 46.89. You can also tell by the curve that the data is higher for athletes and non-athletes.
We can make our sample bigger, reduce bias by surveying all people in a classroom, and we can use a histogram instead of a bar graph so that there is a range of ounces that someone can choose from, instead of just bottles of water, changed into specific ounces.
Thank you for your time.
Have a
And
good
have a great
day.
day.